So today we're going to talk about the idea of reciprocal functions. So this is our third unit. And the first function we're going to look at is a reciprocal of a linear function. So the big ideas that we're trying to get a hold of in this is identify key features of a rational function and apply these key features when sketching a graph of a rational function. So what is a rational function? So when you take a polynomial divided by another polynomial, that's a rational function. And that's going to be some of the things that we're going to be looking at throughout the whole unit. For today's lesson, our polynomial on the top is going to be just a number. It could be 1, 2, but nothing with x in it. Some of the key features that we should be able to look at or determine is what is the domain and range, what are some x-intercepts and y-intercepts, if they're there, we're going to look at some asymptotes. So there may be more than one vertical asymptote, horizontal asymptote. How do we do this? All right, that's what one thing that we're going to show. We're going to look at where the function is greater than 0 or less than 0, and we did that. We're going to use the same idea from Unit 2, from our thinking. We can look at the slope of a curve as being positive or negative, or increasing or decreasing, but I'm going to save that for calculus, but those are some things that you can look at going forward. What should we be looking at? We're going to be looking at what are the restrictions of this function. So where is x and y valid? All right. I'm going to give you a little hint. The asymptotes. The asymptotes are going to drive where our function is valid and not valid. We're also going to look at what is behavior as we approach this restriction. So our restriction is our asymptote. So if we went back to our thinking task and we looked at all these functions here, all right, our asymptote are where there's restrictions. And that's kind of what the thinking task was looking at. And what we're going to look at, what happens when x gets really, really big or really, really small. And we're going to be able to do that. Okay? And kind of the big idea here is how do we put this all together? All right? So what do the graphs look like, and how do we apply these properties to sketch these graphs, and how do we clearly communicate them? And there's multiple ways of doing that. So let's dive in and see what we can do. So I've got this function y equals 2 over x minus 3. So the first thing we want to think about this is what is the vertical asymptote? And what the vertical asymptote really means is where the denominator equals 0. So the idea there is what are some x's that I can insert there where it's not valid. All right? So when if I have anything over 0, right? That's not valid. There's an error when we do that on our calculator. Well, when we have that error, that's where our asymptote comes in. That's where our asymptote comes in. So we look at this. I will use some short forms, VA. Well, this is where our denominator equals 0. All right, so that is 3. Pretty easy so far. And what we can do is we can plot this vertical line as a dash. So using my ruler at -3, I know that my graph cannot exist at that point. my graph cannot, my line will not cross that line of the dashed line of the asymptote. And you've talked about and seen asymptotes in grade 11, all right? Then we're going to look at the behavior near the vertical asymptote. So that's, think of it as step 1, step 2. 1, 2, 1, 2. And what we do is, it's kind of like our intervals that we did before. We look at, we have two range where we approach x at 3 on the negative side, so just a little bit smaller, and we approach 3 on the positive side. All right, and then we look at all of our factors that we had before. So all of our factors is 2 and x minus 3. So those are the pieces of my function that I have up here. Well, if I look at this and say to myself, well, let's pick a number that's really close to -3 on the left side. I don't know, let's say we pick x equals 2.5, as long as it's just below it. Well, that is positive. Well, if I put that in there, 2.5 minus 3, that's going to give me a negative answer. So the result of that is we know that we're going to be extremely negative. Okay? So that means the result of this is we're going to be kind of way down here. So the result of this, so I can think of my f at x as that, it's actually going to approach negative infinity. Okay? And this is a little bit of calculus, so if you're in calculus, you would do similar things, but that's kind of the idea. Now I pick a number that's really close to 3 on the right side, so on the right side of my graph. All right, so 3.5, that's positive. Hey, that's positive. So for that function, it's going to be positive infinity. So what ends up happening is I'm kind of looking at my behavior on each side of the x-axis. All right, so there's the first part. All right, I know I've got my vertical asymptote and I got my behavior near the vertical asymptote. Next thing we need to look at is our horizontal asymptote. And this is kind of crazy, but this is kind of be hard to figure out that. But we want to know what the horizontal asymptote is really telling us. If I scroll up to here. The horizontal asymptote tells us what happens as x gets really, really big, and what is x doing as it gets really, really small. So this is the question that we want to answer. So as we do this graph, what happens when we get really, really negative here, and what happens when we get really, really positive here? And that's kind of the idea. So what we do is, there's two ways of doing this. What we end up doing is putting in really, really big numbers. So for x. So it's kind of like looking at our behavior, okay, as x approaches negative infinity and x approaches positive infinity. Well, and we can look at that and just even putting in f at negative infinity, right? 2 over x minus 3. Well, that's 2 over negative infinity minus 3. Now, you're going to shake your head and say, what the heck? Well, here's the thing. One of the things we say is when we take a really, if I'm looking at this quantity is going to be a really large number. So the question is, what happens when we take a really kind of a small number and divide it by a large number? What does that look like? So if I said 1 over 10,000, all right, well, that is 0.00001. But we could get bigger than that. Maybe it's 1 over 10 million. All right? This becomes really, really tiny. It actually approaches 0. So as this case is, as x approaches negative infinity, f at x, the result of this, approaches 0. So this is approaching 0. So what that means is, if I went back to my graph here, and I say to myself, what does that look like on my graph? What this looks on my graph is, what happens is I'm going to be approaching there. Because this is where f at x equals 0. So y equals 0 is our asymptote. We could do the same thing for this one. So we have f at positive affinity. Well, that's 2 plus affinity minus 3. Well, that ends up being a small divided by a large number. Well, we're going to approach 0. So what we can say from this is, as x approaches positive affinity, f at x approaches 0. And as x approaches negative affinity, f at x approaches 0. All right? So this is kind of what we're trying to prove. Okay? And just to show proof of kind of what we're doing, I use Desmos, all right? And on Desmos, it's not going to really show you the asymptotes. One way of showing that is you can actually type in y equals 3. No, it actually tells you which asymptote should be, so this should actually be x equals 3. All right, so I can see how that graph never crosses that blue line there or down there. So that should give me a good understanding of that. And I can put in my y-intercept, which is 0. All right, and I can see as I get really, really big on the x-axis, never crosses. As I get really, really, really there, never really crosses either. So that kind of proves that. The other thing is you can click on the y-axis, and if I take negative 2 divided by 3, I get negative 0.667. So that tells us that our graph here looks really good. All right. The last thing we have to do is our domain and range. Right, and we'll tidy this up in a few minutes. So our domain is any x values that I can use. Well, the only x values I can't use is the asymptote. Same with the range. Right? So this is where am I putting in my asymptotes? I'm going from there. So that kind of highlights all the things that I was able to do. So these are, think of this as your checklist to go through those. How we communicate this thing, we can look at refining those things, but that's kind of the idea. So if I was thinking like my major steps is when I have a function that looks like this, and we can have one that looks a little bit different, but it's not going to change. All right, the goal is to determine the vertical asymptote. It's where the denominator is equal to 0. We're going to determine the behavior near the vertical asymptote. We're going to use a chart to kind of keep that in mind. And this is a good baseline moving forward. The horizontal asymptote from now is x equals 0. And we're going to get to the point where we're going to be able to show you where it might change down the road. We can look at the horizontal asymptote using interval chart, state the domain and range, and if we can find the y-intercept or x-intercepts, that's a good thing too. Okay, so if that was confusing, go back, re-watch it, see if those steps make sense. As you go over this next example here, hopefully we will catch up on some things. Feel free to pause at any time to check your thinking, maybe go ahead and try it, give it a go. All right, second example, I got f of x equals negative of 3, 2x plus 5, a little bit different, but same thing happens. Vertical asymptote is where the denominator equals 0. All right, just like we were finding the zeros from before. These are asymptotes. All right, and then you want to plot it. Plot it. All right, negative 5 halves, which is 2.5. It's about there. All right, we want to look at the behavior near your VA. And this may be a little bit different, so there might be a little trick with this one. All right, so we want to approach negative 5 over 2 on the left side. And we want to approach this on the right side. So think about the interval going from the left. This is the right. So let's say we picked negative 3 here as our test. X equals negative 2 as our test point. The question you have to ask yourself for this is, what are their factors? Well, 2x plus 5 is a factor, but some people would write down just 3. But remember, it's a negative of that, so I make sure that I have that portion in there. Okay. So, again, as I put negative 3 in there, that is a negative, but this is a negative. So we know that we're going to be on the positive area. And if I put negative 2's in there, that's a positive, that's a negative, that's a negative. And the only thing that's different here is the result. So as we get really, really close here, this is always going to be positive affinity. And that's going to be negative affinity. So I go ahead and plot these arrows. All right, so I'm going to go and plot these arrows. So on the left side here, I'm going to be positive. And on the right side, I'm going to be negative affinity. So this is where f of x approaches negative affinity. This is where f of x approaches positive affinity. All right. My horizontal asymptote, we're going to look at where what happens here. So we're going to say as x approaches positive affinity, we're going to actually put in positive affinity, a really big number into this. All right, 2 times affinity plus 5. All right, so we're looking at what that happens. All right, so this is a small negative, and that is a large positive. All right, so that is approaching 0 because this is very large. Same way as negative affinity. -3 to bracket negative affinity plus 5. This is a small negative. This is a large negative. So it actually approaches 0 on the positive side. This one approaches 0 on the negative side. So if I look at this, as I approach positive affinity, that means way out here, we're going to be below the x-axis because it's a really tiny negative number. As we approach negative affinity, way out here, we're going to be just above that. And then we can connect the dots. All right. And then that, in that case now, we can just state our domain and range. All right. And our domain and range can be based off the picture. All right. So here, f of x, x er slash x cannot equal -5/2. My range, f of x er such that f of x cannot equal 0. So those are my asymptotes. So my horizontal asymptote here, y equals 0, or h of a, or f of x equals 0. So that, and those things. So lots of little things that drives this. All right. We could do a quick check about the y-intercept. So -2 times 0 plus 5. So -3/5. Now, maybe I should make my graph to go up a little bit more like that. But that's how I can do that. So in the end, these are the steps that I should feel really good about. Okay? This is how we get there. And we're going to kind of continue on with that thinking so that you feel good about that. All right? And then at the bottom of the page, there's some graphs you can try. All right? You can check using Desmos. So when you're done, the thinking should drive the graph.